My name is Xian. The subject of the report is the design and implementation of dynamic custom projection system. The directory contains introduction, literature, review, methodology, results, and conclusion. In recent years, real-time dynamic mapping projection technology has been proposed, which has changed the world of precision and integration with the world, combined with the application of artistic expression in multiple 3D models. It combines surface alignment and surface transformation technology to project plane shape and complex geometric target objects. In the past, academic research, most of the dynamic mapping projections are presented on screens by creating 3D models. This paper is based on this photo. Model matching is the use of point cloud data to match object intention, and this photo is idea of dynamic projection mapping to check facial expression. The human body surface is used as the projection target to project a 3D model of the human body. Virtual clothing try-on has attracted more and more attention. However, most of the virtual fitting rooms are retouched. This paper hopes to present to virtual fitting rooms in 3D. There are many kinds of data structure presented in a 3D model. The class, method of model precision depend and fit target object and structure surface representation. Projection mapping using various surfaces as projection targets, such as large building model, sculpture, product assembly model, and even human body. The main purpose is to calculate three-dimensional spatial feature and the relation between these surfaces. The relevance of line sculpture project will be discussed below to provide a technical overview of several issues. In the case of rigid projection mapping, only the target object and the image are rotated and translated to achieve the corresponding relationship. This paper using an altitude mapping reference system sensor installed in the source model to improve the real-time alignment performance and enable phase changing. In the case of non-rigid projection mapping, the deformation and alignment in the non-rigid case usually requires a more reliable corresponding relationship to define a left more DOF to correspond to the non-linear rate. or partial expansion or contraction of the targets. This paper using blend wire along with the phase position and the current type are used to blend the texture mix. Creating and single texture, the rest is that of the aforementioned. Measure for the final projection are image. Most of the virtual meeting rooms are retextured. Only consider the X and Y real-world contents. Segment the crossing from the 3D image, linearly stretch to the baseline of the coloring and light and shadow of the file in the actual 3D image to the new class of the. At first, we have the human 3D mesh interpreted by kinetic and virtual custom 3D mesh. In order to reduce the computational cost, we reduce human 3D mesh and virtual custom 3D mesh by eliminating redundant points, reduce to the reading true phase and have the same number of points on the reduced point. Each iteration of ICP, we will have a new virtual custom 3D mesh that is close to human body 3D mesh. The process would be repeated until the distance between human body mesh and the new custom mesh of each iteration is low or threshold. Let me we have rotation R and translation T, which make the human body mesh and the new custom mesh closer. After getting new custom mesh, we rescale custom mesh to have same review between human body mesh and the custom mesh. In order to obtain accurate experiment, relearn and accurate matching effects, it is necessary to remove duplication, and vertices of simplify and retain important 3D model details to improve subscreen model rotation, translation, and subsequent scale matching efficiency. This shows that in the model captured by the kinetic centrally, camera there may be many overlapping vertices in the coordinate of the vertices in a triangle. The removal of overlapping vertices allow the 3D human body mesh to be reconstructed, remove unnecessary redundant points, can make the rich structure of the 3D grid model different and reduce the time and space complexity of the model. User critique educators this meshing method to simplify the model. You can see the surface changing the model simplification process. In the ICP rotation and translation model, source model A and target model B use the SVD algorithms to calculate the location R and the translation T. ICP instead of the sum model from different perspectives. There are too many data problems in the calculation of 3D data for larger model. At this time, it is necessary to use the ICP algorithm iterator to speed up the efficiency of model matching. Use the KD tree to split the space vertices of source model and the target model B, and repeat this process until the nearest model vertex is searched. Use SVD to calculate the relationship between the two 3D model matches and calculate the rotation and the translation from the source model A to the target model B. Calculate the Euclidean distance relationship between the vertices of the source model A and the target model B, and scale the target model B to changing the size of value. First, the central point coordinates of the two models will be calculated. Calculate the sum of the distances from all vertices of two 3D models to the centrally of gravity coordinates. Calculate the volume radius of the target model B to be scaled. Every room size of the XYZ axis of the target model B. Scales the XYZ axis of the target model B. This is the source model A and the target model B. Experimental model and geometric measurement related information. This is the model surface change before and after remove duplicate vertices. This is remove duplicate vertices iteration time. During the experiment, the experimental model reduced the number of overlapping vertices by 82.67%, reduced the calculation time by about 79.96%, and expectedly reduce the complexity and calculating time of the experiment. In the effect, of vertex simplification. This is the average intelligent time of different number of vertices. The experimental model takes V equal to 5,000 and V equal to 40,000 with 15 iterations as an example. Taking V equal to 5,000 as an example, iterative method take about 57 seconds and V equal to 14,000 as an example. Iterative method take about 475.09 seconds, which reduces and conversion time by about 88%. The mentioned effect of the clause in the experiment model is still effective matching in the iteration of the experimental matching. The model data with less time is selected, which effectively reduces the calculation time of the model experiment process. This is the final matching fate of different number of vertices. This is the KD tree iteration time. It can be seen that there is a significant decrease in the iteration time using KD tree. This is ICP rotation and translation variation result. This is the mean square error of source model A and task model B. It can be seen that MSE tends to be flat, which means that the current model matching the human model. This is the changing graph of the mesh surface area that changes the class value each iteration. It can be seen that the class model has changed with the human body model. In a dynamic clothing projection system, the matching effect of the human model rotating with the y-axis. In the dynamic model, MSE will also tend to be flat. In the MSE summary, the closed model at the beginning of the iteration has not completely matched the human. After 22 iterations in the iteration group, the MSE tends to be flat until the human model is rotated to 270 angles. The closed model and the human model are perfectly matched. This is dynamic model projection effect. This article introducing a fully automatic 3D model visualization method in the iteration. The 3D clothing model is rotated, translated, and ruled. The experimental results show that under the condition of no noise and redundant points, the corresponding relationship selected by ICP improve the computational efficiency. It is becomes small and smaller and improve our efficiency.
Thank you for your listening.